So sit back, relax, enjoy the soft melodies of me working through these questions, all right? So let's kind of go through. I know, or ignore me and keep doing whatever you're doing. I'm going to work through them. So let's start with number one. I love this one. It's a little tricky in one sense, but it's a dosing question. It says a pediatric patient who weighs 33 pounds is prescribed a combo drug, sulfamethoxazole and trimethoprim. There are two drugs in this liquid. The dosing is 8 milligrams per kilogram per day. But here's the first trick. 8 milligrams of what drug? Trimethoprim. So we need to remember that the dosing of this combination is based off of the amount of trimethoprim that we need. Easy enough, 8 milligrams of trimethoprim per kilogram per day. That's another trick, because how often do you give this medicine? You don't just give it once a day, you give it every 12 hours, all right? So, because what we want then is the volume should receive for a single dose. So what drug volume of the liquid will provide the amount of drug for a single dose? All right, so there's a lot going on there. But in the end, we want the volume for the dose, which means we need the dose, and the dose is weight-based, okay? The dose will depend on their weight. So let's start this question with their weight. So we'll start with the 33 pounds and convert it to kilograms, but dividing by 2.2, okay? So that's this set, so pounds cancel. Then I'm gonna take my 8 milligrams per kilogram and multiply by that so that kilograms cancel. But this is where I still see some people kind of messing up and forgetting that it was 8 milligrams still per day. Because when you do this, when you take 33 divided by 2.2, you get the weight in kilograms, times 8, that's 120 milligrams, but that's the daily dose. That's the amount per day. So we still then need to bring that down to here and take the fact that they're only getting a dose every 12 hours, which means basically in one day there's 24 hours, and if we do 12 hours per dose, and again, you don't have to do it this way, but this basically just kind of shows you that, again, 12 divided to 24 means there's 2 doses per day. That was a long way of showing you that there are 2 doses per day, so we've got to take 120 milligrams per day divided by 2 to get 60 milligrams for a single dose, okay? Once I know that my total dose for the single dose is 60 milligrams, now I can start the process of converting that weight of a drug to the volume of the suspension that provides that weight by looking at the concentration. And this is the trick here, is it's based off of trimethoprim. So since the drug label says sulfamethoxazole and then trimethoprim, then says 200 and then 40, then we know the second drug is the second number, so trimethoprim refers to the 40 milligrams here, so that's the concentration to use. The fact that for every 5 milliliters, and again it's per 5, there are 40 milligrams of trimethoprim. So that when I divide by 40 and multiply by 5, I get the volume in milliliters. And lastly, just to make this as difficult as possible, I wanted you to express it in teaspoonfuls. Did you notice I did say teaspoonfuls on my question? I passed lab, so anyways, okay. So bring that down to here and say for every 1 teaspoonful, there are 5 mils. Mils cancel, and you should get 1.5 teaspoons full per dose. What would you type on the label? Take 1.5 teaspoons full, parentheses, 7.5 milliliters, right? We'd never just tell them that volume on there, so, okay. Keep driving, Larry. Okay, on that one, it's a dosing question, straightforward but tricky. That's a good example of a tricky kind of dosing question, I would say. All right, let's just move on. So here's a weight, a solid aliquot. In this case, we want to weigh 60 milligrams of a drug, a solid, using a scale that no more than 5% error and an 8 milligram sensitivity requirement. All right, so, okay, let's deal with a couple of things there. So again, you can always look ahead of me. First thing is, let's use these 2 things there to calculate the least weighable quantity. Turns out to be 160 milligrams. Well, that's a problem when I only want 60. All right, so that's an aliquot. So what do? We calculate the multiplication factor. That's the least weighable quantity here, no, don't do that, least weighable quantity divided by the amount of drug needed, the 60 milligrams is what's going to go down there. So 160 divided by 60 gives us 2.7. And I can't emphasize this enough. Even if it came out to be 2.05, what do? Round up. You always, for the aliquots, round up. So again, we go to 3, multiplication factor is 3. So let's take the drug needed times 3 to figure out the amount of actually drug to use. So I'm going to take 60 times 3, that's 180. That's the amount of drug I'm actually going to weigh. Let's set my aliquot weight, the weight I'm going to weigh out at the end, equal to my least weighable quantity, which is 160, and just do that every time. So take the least weighable quantity times the same multiplication factor, okay? And, oh, I'm sorry, I'm up here. 160 times 3 gives us the 480. That's the total mixture weight. So if this is the total weight, and this is the weight of my drug, then if we just subtract those, so that's bringing those down here, subtract the total, subtract the 180, the difference is 300 milligrams. And that means I have to add 300 milligrams of my diluent to my 180 milligrams of drug. 300 plus the 180 gives me a total of 480, mix that all up, and then what do I weigh back out at the end? My 160, my aliquot weight, and this just goes to check my work, okay? So, I just wanted to also show you, if you want a quick way for the exam, remember I showed you this, is once you know the multiplication factor was 3, and make sure everyone realizes, and let me just go back. So all of this work is the same. Everything here is exactly the same. So again, you determine the least weighable quantity, you divide it by the drug needed, round up to the closest multiple, okay, 3 in this case. Well then rewrite that same thing. Rewrite the least weighable quantity over the drug needed, but now go ahead and multiply by that value. If you take the 160 times 3, that gives you the 480. The 60 times 3 gives you the 180. And remember, this number on top is now the total. Once you've multiplied by 3, that's the total weight. The weight on the bottom is the weight of the drug. So if you just subtract going down like this, kind of showing you over here, then the difference will be the amount of diluent you need, 300 milligrams. So if that helps kind of this as a visual setup of how to proceed on with that, so be it. Hopefully that'll help. Okay? And again, this will all be in the keys. I'm sorry to hit the mic if I catch me going too fast. All right, that was the solid aliquot. Let's do the solid liquid aliquot. In this case, we have this drug. We need 0.5 milligrams per mil, and we want to prepare 60 milliliters. To do this, we're going to have a scale that's got a 4 milligram sensitivity requirement and an error of 5%. Going to use a graduated conical cylinder that's 125 mils, but can't measure anything less than 25. So that's the least volume I can measure, okay? And it's marked every 5 mils. So it starts the same way. If it's a solid in a liquid, let's stay with the solid. So my first question to you is, how much drug do we need? If we can just measure it, then we don't have to mess with the whole aliquot. So what is the drug needed? Well, we need 60 milliliters to have 0.5 milligrams per mil. If you multiply those, then that tells you the total weight of the drug for that liquid for 60 mils is 30 milligrams. Sadly, that's less than our least weighable quantity that we're going to prove now, because with a 4 milligram sensitivity requirement and a 5% error, we use the formula, then I find out that 80, in fact, is the least I can measure. So I cannot measure less than 80. So we got to do the aliquot with the multiplication factor. What do we stick on top? Least weighable quantity. What goes in the bottom? Drug needed. Least weighable quantity divided by drug needed. We want, our least weighable is 80 and we want 30. So again, it turns out to be 2.7 again. So a multiplication factor of 3. Easy enough. So what's my quantity to actually weigh? I'm going to take my 30 milligrams drug needed times my multiplication factor. I'm actually going to weigh 90 milligrams. Yay for me. What am I going to do with that? That's too much. I'm going to dissolve it in water. How much? Well, then look at the apparatus I gave you, and I told you what the least weighable, least measurable volume was, which was 25 mils. So in that case, we're going to set my aliquot volume equal to that least measurable volume. So my aliquot volume is 25 mils. So what do? We take the aliquot volume times the same multiplication factor, and lo and behold, that's 75 milliliters. What that means is I'm going to dissolve 90 milligrams in 75 milliliters. But that's too much drug. I don't want all 75 milliliters. What volume of that drug, of that liquid, gives me only 30 milligrams? And that's basically your aliquot volume. That's the 25 milliliters. You specified that already. So again, you're going to measure out 25 mils. And remember, 90 milligrams of drug. We put it into 75 milliliters of fluid. Set that equal to some unknown amount of drug per the aliquot volume. If you solve for that, that's where the 30 milligrams comes from. That's why we're pulling out 25 milliliters at the end. Okay, 25 mils has 30 milligrams of drug. What was the final volume of the solution supposed to be, though? 60, right? Didn't we want that to be in 60 mils? So the last step is to take the 60 mils called for in the prescription, subtract the volume that's going to come from my drug. My drug will take 25 milliliters to provide it. That means I still need 35 milliliters of other diluent or flavored vehicle to make this prescription. Okay? Number 4, this is the liquid-liquid aliquot. I would say the trickiest of all aliquots, in my opinion, only in the sense of determining the multiplication factor. You have to do some mental math. It isn't, and you can do it on paper, but the trick here is this. Look at the drug needed. This is the amount needed, 14.4 mils. The trick to a liquid-liquid aliquot is the amount that you're going to have to measure is more than the least measurable, and we said the minimum is 20, so it's got to be more than 20, but it has to be a whole number. It cannot be a fraction. So just look at the fraction. Do you see where I'm circling the 0.4? What number times 4 gives you a 0 at the end? I would argue, I heard 5, so I like 5, but what about 10? What is 10 times 4? 40, doesn't that end in a 0? And that is acceptable. But my question to you is that the smallest? So again, if you're really dying, try 10. 10 will work with anything with 1 decimal point, but it may have a lower one than that. And the answer here in Lawrence was 5. 5 times 4 is what? 20. That ends in a 0. So that's why I'm choosing 5, because it's the smallest multiplication factor that gives me a whole number. And I know that because 5 times 14.4 gives me 72 milliliters. Is that less than my largest volume? Yes, that's 250 is the largest I can measure, so that's not a problem. I can measure 72. It's a whole number, and it's greater than 20. So I now know my multiplication factor is 5. My drug needed, essentially, is going to be 7. My quantity to actually measure is the 72 mils. I'm actually going to measure 72 mils, which is a 5-fold factor over what I need. Then let's set our aliquot volume. And don't make that, I know this looks long, just set the aliquot volume to the least measurable quantity. Okay, always choose the smallest. I'll always ask you that on my questions. So the smallest you can measure will be given to you in a question when it comes to liquids. So again, I know that's 20. All right, so if my aliquot volume is 20, then my quantity to actually measure, my total, I back up, the total volume to dilute it to is going to be the 20 times the 5 is 100 milliliters. So 100 milliliters is my total mixture volume. That's the total, aliquot volume times multiplication factor. That's 100. Well, if the 100 is the total and 72 is my drug, the difference will be the water. So the additional amount of diluent I need is 28 milliliters. So 72 mils of drug plus 28 mils of water gives me what total volume? 100 mils. But that's not all, that's, what do I want out of that 100 mils? In the end, I'm going to measure out 20 mils. Remember, it always comes back to that aliquot volume. Of that 100 mil mixture, I'm going to measure out 20 mils because 20 mils of this concentration gives me the drug needed at 14.4. Okay? So, I'll just end, well, I don't want to run out of time here. For the aliquots, the endless practice problems, for everything on this chapter, in terms of how to study for the exam on Thursday, definitely today's packet is a good example. I'll talk about the review exam that we're going to do tomorrow night, or the one that's posted. The review exam it was a previous exam from that. That's a good one. So those two things on paper are great. The endless practice problems, I cannot emphasize that enough. I want you to have those down. Half of that exam, up to half, I won't say exactly half, but up to half could come from endless practice problems. So if you want to guarantee yourself, go through all of the endless practice problems that I have linked to for the chapters 1 through 5. If you can do those consistently, you're in good shape. Between those and these couple of exams, you should know what's on the test. I bring it up for the aliquots because my aliquot questions will come straight off of those endless practice problems. They'll be worded the same way. So if you can do those, you can do mine. These were essentially worded the same way almost, so keep that in mind. All right, beyond that though, so that's chapter 3. There's a question here, Lawrence, please hit the button.
For the liquid-liquid aliquot on your practice problems, it's always 10 for the multiplication factor. So is that how it would be on the exam?
No, it's not always 10. And I'll double check me on that. It depends on the number. Again, 10 for 3, if you're 0.3, it's got to be 10. There are definitely numbers where the decimal factor has to be a multiple of 10. But I'm just telling you, we just saw on this one, if it's 0.4, then you're going to have a 5 multiplication factor. And I'm pretty sure on that there are, and that's why I'm saying, if you keep getting 10, just keep hitting new one until you can get one that's different.
Last time I did that was a couple weeks ago though. I did that and there was ones where there could be a lower value, but it was just always 10.
No, well, talk to me on that afterwards. So I would say, in that example, if you're confused, I would say use these examples. And we've done this one today. We've done one in the chapter 3 packet, both the homework and the regular one. Use those examples because those factors weren't 10. So I would argue that no, on the test, do not just assume a multiplication factor would be 10 for a liquid. There would be other reasons to do it. So, and I apologize that the endless practice problem is acting weird. So use maybe the examples here. Okay. So that was chapter 3. Chapters 4 were kind of the prescription interpretation stuff, so I won't belabor this point. I would just remind you on the exam, I do expect you to know Roman numerals, but the QID, BID, and so forth, I will either give them as actual twice a day, 4 times a day, and so forth. So you don't have to know the Latin abbreviations, although it still doesn't hurt. But anyways, in this question, here we've got 6 capsules 4 times a day. So there's capsules 4 times a day for 7 days. And then just be organized and do that all the way down. So I like these kinds of questions not because they're difficult, but because in pharmacy, you can't make a mistake at any step. Would you agree? In this case, there are 4 steps. They're easy steps, but along the way with your calculator and with your math and sometimes your mental math, it's easy to make a mistake along the way. So this is more of a question about precision than it is about difficulty, but you might see a question like that. Is everyone clear? Kind of understand it. It's not a hard question, but you got to make sure you do every step right or you end up with the wrong number. So and also check yourself at the end to make sure. In this case, by the time you do all that, it's 310 capsules. I won't belabor that point. This one is, again, a day supply one, pretty straightforward. The trick is being able to know how many dosage units per day are they going to use. They're using 2 puffs at a time. So every time they inhale, they're going to inhale 2 puffs, and they're going to do that how often? 4 times a day, and they're doing it by mouth. How many mouths do you have? Just 1. Unlike nostrils or eardrops or eyes, there's only 1. So 2 puffs by mouth, which is just 1, times 4 doses per day, you can see that ends up being 8 puffs per day. Obviously, 4 doses at 2 inhalations per dose is 8 doses per day. Take the total. In this case, I know exactly how many doses are in my container, which makes it easy, 90, divided by essentially the number of puffs so that the puffs cancel, and 90 divided by 8 rounding down would be to 11 days per inhaler. Okay, not difficult math. And again, please, I'll just remind you on my questions, read the whole question, including what are the final units. And again, if I do want you to round up or down, usually I will give that to you in the question, except for, okay? All right, last one here, and this one was not super difficult. I like this one because, and I'll just show you my answers. I like this question because there are a lot of steps. So once again, it's about precision. It emphasizes a couple of things we've been practicing, which is unit conversions for metric. Will I give you metric conversions? No, I will not give you metric conversions. So you need to know how to go from micrograms to milligrams, milligrams to grams, and so forth. So make sure you know your metric one. So the example here of just converting milligrams to grams, while it's not difficult, you need to be skilled at it and make sure that you can do it consistently every time it needs to be done. Okay. What was new a little bit here is chapter 5. Do you remember what we talked about in chapter 5 from the textbook? Specific gravity. And we said that specific gravity is the same thing as density, so long as you use what units? Grams per milliliter. So when I say here when I say 1.24, you're going to write 1 point, and I can't do this with my finger very well, grams per milliliter. Remember, you add the units at the end so you know how to deal with it. So if it's 1.2 grams per milliliter, how do I use that? Then down here is to convert milliliters to grams, I multiply, because multiplication cancels milliliters and gives me a weight in grams. And you can say I did that again down here for the oil. You may very well have to go the other way. You may have to divide by the specific gravity if I want to do what? Convert essentially a weight to a volume. So again, go back to chapter 5 questions. There were examples of sometimes we used the specific gravity to convert weight to volume, and sometimes volume to weight. And make sure you just set the units here so that you cancel what you want to cancel, and that will drive whether you multiply or divide by that number. Okay? In the end here, all you had to do was add everything up. So when we add all that up, we got a total of 27.6 grams, but this was for a batch of what? 24, and it wanted the amount for a single troche. So again, you take the total divided by what the number it's going to prepare, and that's where I got my 1.15 grams per troche. Okay?